Okay, welcome. Thanks for everyone coming in. We actually have a lot to do today, so I'm going to share my desktop right away. And let's take a look. Okay, so welcome again. I don't have a long list of things to do, but I got two big chunky items to do. So let me tell you the plan today. I'll answer some questions if you have questions. And then after that, we'll talk about comparing two proportions. Pretty much everything I do today is going to be with the example in terms of new material, because the new material actually, there's very little that is truly new. It's more of a refinement from last week. So just let you know, but we want to be able to compare. And it turns out that I would say, I don't know, there's probably 5 times more comparison studies than there are single studies. So this chapter is much more important in the real world than the last chapter. The last chapter is kind of to get your feet wet. And now it's time to dive on in. So we're going to compare two proportions. And then we're going to compare two means from independent samples. And then we're going to compare two means from dependent/paired samples. And something I made up, by the way, is I call it play the tweet for my example I'm going to give. And you'll see it's a money example. And I did make tens of thousands of dollars. So yeah, I was pretty happy about it. Okay. So we'll talk about what it's about and how I made so much money. And it wasn't for working from, get paid to do statistics. It has to do with the stock market. So then we'll talk about project 2. Okay. And in fact, I think I'm going to get those. I'm going to switch them around. So after that, we'll talk about the exam. Just a little easier in terms of the screen. And then we'll talk about project 2. So we got 2 major things that are coming up. So the exam, when do you get to take the exam? Can you remember?
Thursday, Saturday, or Sunday.
Yeah, Thursday, Saturday, or Sunday. And exactly one of those 3. So, don't think you can take it all 3 times. That's not what you should do. So pick your time, take it, and hopefully it'll go well. And I do want to let you know that if you receive accommodations for disability, you have to let me know which day you're taking it so that I can make that happen on Canvas. Just send me an email is all you have to do. It doesn't have to be public. In fact, it shouldn't be public. But send me an email and say, I'm taking it on this day at this start time. And as long as 2 of the hours that you're taking it are during the time of the exam, then that's acceptable, is the way I go. So just let you know that you do need to send that to me. If you don't send me the email, don't assume I know what day you're taking it, because that's, I don't read minds. That I can't do. So anyhow, that's a plan for today. And I want to mention a couple things. One is this week is a very light week in terms of new material. I don't know if anyone's even looked, but did you notice the discussion post assignment? Anyone notice? Yeah, there is none. Okay. This is really the only time there's no discussion post assignment. Uh-oh. I hope we're still okay. Something weird happened. I clicked the wrong button. So there's no discussion post assignment. We do have a chapter assignment, and there is going to be a secret word quiz, but that will be easy because you're here. So just to let you know, I lighten up so that you can focus on the exam and your project, because that's what this week is mostly about. Any questions about that or anything else?
I have some questions about the homework for chapter 9.
Uh-huh.
So I wanted clarification with the first one. When I was inputting data into the calculator for my first problem, I'm assuming, is that mu naught, the mu with the 0?
Yeah, mu naught is a mu with the 0. Yeah, that's the
Okay.
British way of saying 0.
Okay, yeah.
So sorry about
So,
that, but the
that's
British
okay.
got there before the Americans for
That's
statistics.
okay. I used the mu proportion. So, I mean, not the proportion, sorry. Anyway, it was 74%. And when I put it into the calculator, I did 0.74 and that was incorrect.
Okay, so first thing, the 74% was a survey question, a yes, no question. It was a percentage of people who said yes.
Yes.
Then there is no mu.
Okay, but
That's a worry right now. You're using the wrong calculator because you're using probably the hypothesis test for a mean, right? But there's no mean. This is a proportion.
Well, when I put the 74 without a decimal, I got it right. So maybe I was using the wrong calculator. I wish I could.
Yeah,
Well,
I'd have to look at the problem.
okay,
It
that's
could
fine.
be
I
a
can
problem
maybe.
at which many people took a test, and the average score was 74%.
Okay, that may have been the one. I didn't write down the full
So it could be
question
that.
on my notes.
Again, it's hard for me to know.
Oh, it was that question, the average exam, 74%. So I put that into that, but when I did
Yeah.
0.74 in the calculator, it was incorrect. So is
Because
there a
right,
reason
because
for
the
that?
problem itself gave you 74%. So that's all it gave you, which means you should use 74.
Okay, great. So I got it right eventually. My next one
And
is
just let you know, but I want to mention this. I know you want to talk for just a second.
Yeah.
Is that if this kind of stuff happens on the exam and you're not sure, what should you do?
write it in my put my work out my problem in the chat box or text box.
In the right. Make sure you write down your reasoning, and then at most you'll lose a point, probably a half a point or something like that. Does that make sense?
Yes, because you'll see that we tried to do the right thing.
Yeah, you had the right idea and you made a mistake that was very, very minor. But if you don't put anything in the box and all you have is a wrong answer,
Yes.
then I can't give you points. Does that make sense?
Yes. So on 2 other questions, when I inputted the information into the calculator, I'm fairly certain I did it correctly. All the other, well, the T or the Z was correct, but my P was wrong.
My guess is that usually means, not always, but it usually means you chose the wrong tail. So you probably had the inequality wrong.
Okay. Yeah. The third one like that, I got correct. And then, from there on, I got them all correct.
So that usually, and that usually means you have the inequality wrong. So remember, if you're doing if H naught is mu is less than 5 or something, you got to put a less than. You got to click less than. You can't.
Oh, okay.
So pay attention to that with hypothesis.
Oh, I think that is. Okay.
Yeah.
I felt like I was doing that part right, but that I can, when I go back to practice, I'll check that out.
That's my guess.
Then,
again, I can't read your mind, but that's my best guess because I can't think of anything else that would go wrong other than that. If your test statistic was right and the p-value wasn't, that almost always means that you chose the wrong tail.
Okay, that makes sense. Yeah, because it was I got 0.0008, and then the correct one was 0.0013.
Okay, really? Okay, because I was saying that sounds like 2 tails. Doesn't sound like right, but I have to look at it,
Okay, I can I wrote the question down and stuff, and I can maybe give it to you. And then just to clarify, I'm trying to understand the relationship between P and alpha, when we want to say like P is greater than alpha or P is less than alpha. What is that relationship? How does P and alpha's relationship determine the outcome?
Okay, so the p-value is the probability of the outcome happening with the sample given the null hypothesis is correct. Okay, so that's what the p-value is. So if the p-value is really small, then you're going to say, well, that's too unlikely. So that given that the null hypothesis is correct is probably wrong.
Right.
If the p-value isn't that small, you're going to say that's not very unlikely. Do you see?
Okay.
Now, the level of significance is the boundary of what unlikely means.
Okay. So yes, so let's say for instance, alpha is 0.05 and P is 0.1275. Because P is greater than alpha, then we would fail to reject the.
Right. And the idea is because there's a 12% chance of that happening just randomly if H naught is true. And your definition is if you're not under 5%, then There's no reason to think that the assumption H naught is true is wrong.
Okay, so alpha kind of gives us that boundary of anything greater than this, then that would be wrong, even if it's 90% or 10%. If it's greater than alpha, then we would fail
Right.
to
We don't use the
reject.
word wrong. We don't use the
Sorry,
word
fail
wrong.
to, yeah,
We
fail
fail
to
to
reject. So
So that's
yeah.
very important.
yes.
And I do want to mention, because I did grade your, I mean, not you personally necessarily, but yes, you personally, but everybody's discussion post assignment. Please read my comments. And if you've got lost any points, make sure that you deal with the question before you take the exam. Because you're going to be asked that on the exam, and I'll show you what you're going to be asked. And if you do it again, then you lose points. But losing points on an exam is much worse than losing points on a discussion assignment. So that's a big thing, is make sure you look at my comments, because a lot of you made at least one error in the analysis. Most of you, actually. It doesn't mean you like you screwed up the whole thing, but there's at least a few tweaks you can make, everyone. Okay. Or
I got a quick question. So is that Z and the T, is that the Z? I'm confused what that actually is. I was finding it, but I don't, was that Z the Z score? Or is it something else?
Kind of. It's a Z score for the sampling distribution. And which is, hard to understand. But the idea is the Z comes from a normal distribution. Z always means standard normal distribution. That's what we use that letter for only. And the idea is the central limit theorem tells you that if you have a sample with a large enough sample size, then you're always approximately equal to normal. Your distribution is approximately normal. So that's why you can use Z. On the other hand, if you don't know the standard deviation of the population, which is pretty much always the case, then you have to do that adjustment, and that's what T does. T does the adjustment for that. Does that make sense?
A little bit.
Yeah, and I will let you know on the exam, I will not give you a problem where you know the population standard deviation. Okay, so for the exam, T is going to be used for proportions, and Z will be used for proportions, and T will be used for means. Because with means, you need to do that adjustment with the standard deviation issue. And if you don't understand, please, ask for follow-up questions. You can ask now, because these are all good questions. You could also ask Braulio in office hours, in his hours. You can post on the Q&A forum. There's lots of places. I'll be checking. I'll probably be sleeping a lot tomorrow, but I'll be checking at least some tomorrow. Hopefully I won't sleep through office hours tomorrow. I'll do my best.
Are you feeling okay?
I'm feeling okay, yeah. But it's the next day that's supposed to be the worst. So
Okay.
we'll see. Feeling okay. I'm a little shaky. Like literally. My body's shaking.
Like feverish, shaking?
No, just shaking. Like
Okay.
Yeah, maybe it's fever, but I don't know.
Okay.
I don't own a thermometer, so whatever it is. So anyhow, okay, so any questions? I see on the chat. Could you repeat the definition of P? Was that what you were asking? Or you want it again? So P.
Yes, please, if you could say it again.
Yeah. So P is the probability that if the null hypothesis is true, and you did another study with the same sample size, or today it'll be sample sizes, then it's the probability that you'll get such an extreme value or more extreme than what was obtained from the original sample. So that's what P is by definition. And the idea is, so if you're doing a p-value for mean, and your hypothesis was that mu is equal to 10, and H1 was mu is greater than 10, and you got 12 for your sample, then it would be the probability that if mu is 10, that you get 12 or bigger. That make some sense?
Yes, thank you. I had that completely backwards when I was doing the homework. Thank you.
Yeah, and that's
So
if
if-
you did another study with the same sample size.
If P is 12%, then there's a 12% likelihood or chance that you can be,
As
you would
extreme-
get different results with
not different, but at least as extreme results.
at least as extreme.
Yeah,
So
there's
there's
a
a
100% chance you get a different result, it turns out. 'Cause
Okay.
If you're going for, a continuous distribution, then any exact number is always 0%. But
So the
Yeah, I'm right.
lower the P is, the greater the likelihood that your results would be similar if you did another group with the same experiment.
no, the exact opposite. The lower the
Mm.
P is, the smaller the likelihood, because P is the
Okay.
likelihood.
The P is the likelihood that you
Yeah,
would get
so
the
if P is
same or as
0.02,
extreme or more extreme
Yeah,
results.
so if P is 0.02, then there's a 2% chance of getting something as extreme as what you got. Do you see? If H naught is
Yes.
true. Yeah, and that's
Okay.
if H naught is true, always assuming H naught is true. If you don't assume H naught is true, you can never find a probability.
So what do you mean when you say extreme?
Okay, so I use the word extreme because there are 3 types of tests. There's a less than, a greater than, and not equal to, right?
Mhm.
So a less than, that's a left-tailed test. So extreme in that case means that or smaller. If it's a greater than test, a right-tailed test, then it means that or bigger. If it's a two-tailed test and not equal to test, then it means you grab what you got and you say bigger than that, or on the other side, less than.
And when you're saying that, that refers to the sample,
Exactly.
either proportion or mean.
Exactly, yeah. The p-value always refers to the sample as a probability.
Okay, so it's if the null hypothesis is true,
Mhm.
then it's a probability that you would get what you got from your sample, or
Or more extreme.
farther, or
Yeah.
deviating farther from the null.
Right, and that's what it means.
Okay.
Left or
It says-
right.
Right, how unusual is it to get what you got or even worse? Do you see?
Yeah.
Or even more extreme. And I use extreme because then you don't have to go and say left tail, right tail, two tail, and they're all different.
Yeah, that makes sense.
But it's important that you understand it, on each side.
Mhm.
And because two tail, you have to find the left and the right,
So I'm sorry, just one more time. The lower the p-value, the more likely it is that the hypothesis is correct.
Not quite.
Or do I
Not
have that
quite.
backwards?
The lower, no, it doesn't, that doesn't work. The p-value does not tell you the chance the hypothesis is correct or incorrect. The p-value tells you the chance that if the null hypothesis is correct and you did another study of the same sample size, then you'll get something as extreme as what you got. There's no way of shortening this. So don't try to. It just can't be shortened. I'd love it if there was an easy way of saying it, but there isn't. Any other questions, or can I jump to the new material? Okay, let me jump to the new material. And so far, everything we did in chapter 9 was deciding whether a mean or proportion is bigger or smaller than or not equal to a certain number. And the problem is that one is often you don't have a number that you want to check with. Does that make sense? So, and the other is you often want to compare two different groups and see who's more or who's less. Does that make sense? And that's a very, very common type of hypothesis test that is done in the real world, is comparing two groups. So I'm going to do all of these by example, one example each. So here's the first example. So the first example is there a difference between the population proportion of American Hispanics and African Americans who think that race issues is the most important problem in the United States? Okay. And by the way, I will tell you this one I got from Gallup, so you can quote me on these numbers. So the Gallup poll, whereas the second one, by the way, I made up. A recent Gallup poll found that 34 of 180 Hispanics think so. 17 of the 134 African Americans think so. Use a 0.05 level significance. So any questions first on just reading this? What it's asking for? Okay, if there's no question, I have a question for you. What is the survey question? What are you going to ask all these people?
A yes, no question?
But what question? I want to hear the question. You're not going to just look at someone and say yes or no. You're going to actually ask a question.
Oh, is race the most important problem in the US?
Good. And if you so that's always the first thing you should do on these is look at the paragraph and say, what is a survey question that you would ask the person? Or if you're going to do some kind of experiment, what numbers or answers are you going to write down when you're done with the experiment if it's not a person? Any questions on that? So hopefully you see that this is a yes, no question. Is that clear? Okay. And I do want to let you know that chapter 10 is not on exam 2. It is on the final exam. But if you don't understand how to do any of this stuff, you won't understand chapter 9, and chapter 9 is on the exam. Because it's a hypothesis test. And mostly it's just the same. Like, is it yes, no, or is it a quantitative? If you don't know how to do that, you can't do chapter 9 either. So that's why I can spend some time on this, and it's still kind of a review for the exam. Okay. So that's the first thing you ask is, what was the survey question? Is it yes, no, or is it a quantitative? Now, we have learned about sample sizes. And again, this will help you for the exam too, is that with a yes, no question, do we need over 30?
No.
Yeah, don't go there. Got it? It's not about over 30. What is it about?
NP.
What about NP?
Is it more than 5?
Yeah. And also, not just NP, but what's the other one?
NQ.
Yep. We need to look at NP and NQ. So that's the first thing I'm going to do. So NP, but it's a little different now because there's 2 groups. There's the Hispanics and the African Americans. Is that clear? So I need actually an N1, P1, which I'll let it be the N1 is the sample size for the Hispanics, just because it came first. And P1 is the proportion of Hispanics that said yes. Why do I not have to do any calculations? Why can I just write down the number without any math? You have to know how to read.
It's
What is
given
it?
in the question.
And what is it? I'm looking for a number.
Oh gosh, I'm sorry. I can't see your screen. I
Can't see my screen? How about
no,
everyone else?
I exited full screen and it's hard. I
But the rest of you can see my screen?
Yeah.
Okay, I just want to make sure that it's, because I don't know. I mean, I think.
No, it's there. I just exited full screen, and
Oh, I
so getting it back to big is
So who knows what M1, P1 is then? I'm looking for a number.
For which group?
So I'm letting the first group, just in order at which it's written, be American Hispanics.
Right.
Would it be 34?
Yeah, that's going to be 34. So you don't have to do any math because it's given. Because remember, N1, P1 is the number of yes answers for the first group. Again, there's not too much new here. Do you agree so far? Other than I have a subscript 1, so I can focus on, Hispanics first. Okay, what about N1, Q1?
Would it be 17?
No, because that would be, so 1 I'm letting be the Hispanics, 2 I'm letting be the African Americans. We'll get to 17, but we're not there yet. So Q is, remember, P is the proportion of yeses. Q is the proportion of no's. Okay, and this one you do a little math, but it's pretty easy math because N1, Q1 will be the number of no answers.
146.
Yeah, it's 146. And we get that by taking 180 minus 34.
oh 180.
And you're always allowed a calculator. I never tell you can't use a calculator on an exam or homework or whatever. Any questions on that? Okay, then we're going to do the same thing with N2, P2. And what is that? Here's a hint, you don't need,
17.
yeah, that's 17, because now we're focusing on the African Americans. And how about N2, Q2?
117.
Yeah, that's 117, because if you take 134 and subtract 17, that'll give you the number of no answers, right? You take the total minus the yeses, give you the no's. Okay, what do you notice about all four of these numbers that were kind of the whole point?
They're all in the paragraph.
Actually, they're not all in the paragraph. They're all bigger than 5.
Oh, yeah.
So I'll write CLT for central limit theorem tells us that we can use a normal distribution. Any questions on the first step here? Okay, so now that we can do that, now let's actually do a hypothesis. So we're going to have an H naught. What letter do I use? Is it P or mu?
P.
Yeah, and I need a number too. It's P1 equals P2. Okay, or if you want to write PH equals PA, that's okay. Hispanic and African Americans. So that's totally up to you. Any questions on the null hypothesis?
You're saying that the proportion of Hispanics is equal to the proportion of African Americans as far as who answered yes.
Exactly. Who answered that race is the most important problem in the United States. Okay, HA. What's that? I'll start you out. P1.
Not equal to P2.
Yeah, so, and what's the key word that it's not equal to? There's one key word in the paragraph. And I do want you to like get that focus down on what the key word.
Difference.
Yeah, difference. Is there a difference? And difference is a not equal to. Does that make sense? If they're different, they're not equal to each other. Any questions on H naught and H1? Clear so far? Is this feeling any real difference between last week and from last week? Or do you see that it's pretty minor? Yeah, it's basically the same as last week. But now we can actually compare 2 samples instead of just 1, or 2 populations instead of 1. Okay, well, if you want, again, you can talk about the type 1 and type 2 errors. In this case, 0.05 has already been given to you as a level of significance, which is standard with kind of race-based issues. You almost always use 0.05 and sociology, and this is definitely sociology. Okay. But a type 1 error would mean that you decided they were different and then they were the same. So maybe you're going to advertise in such a different way. I don't know. But you did that and then you didn't really need to. You could have just sent the same ad to everyone. Do you see? That would be a type 1 error ramification. Whereas a type 2 would mean that you didn't notice they were different. You weren't able to say they were different, but they were, and maybe you could have advertised specifically to each group and addressed them. I don't know, you know. But the next step, and I better write this down because I'm not going to remember every word, 34 of 180, and we had 17 of 134. And the next step is to go to the calculator. Which calculator do you think I need to use?
two proportions.
Exactly, two proportions, number 19. I tried to make it easy if you understand the question, which calculator. If you don't, then you're just guessing. Okay, and then I asked you for the sample size, and that was 180 and 134. The number of successes were 34 and 17. Any questions so far? We need to do a not equal to. And just for fun, let's get a confidence interval for the difference. So what do you think a good confidence level might be?
0.95.
Yeah, this is probably 0.95. It's standard sociology. But you could always adjust it and change. The level of significance you can't change after looking, but the confidence level you can. And it calculates. And what do you notice?
The p-value is greater than 0.05.
Right. The p-value is greater than 0.05. Notice the test statistic, about 1.47-ish. We have a confidence interval between negative 0.02, which is basically 2% on the downside and 14% on the upside. So I want to mention the confidence interval. That means that with 95% confidence, we can say that the, so we're talking about first minus second, by the way. So if it's negative, that means the second was bigger. So that means that the African Americans proportion, population proportion, that think that race is number one as an important factor in the United States is no more than 2% more than the Hispanics. And the Hispanic proportion, population proportion, that think that race is more important, most important, is no more than 14% more than the African Americans. Okay, with the p-value is 0.14, that one I'm going to type out. And that's certainly, whoops, greater than 0.05. Notice I didn't even need a level of significance. 0.14 is always bigger than the level of significance. No one uses anything bigger than 0.1. What are the first few words I write down as my conclusion? The hint is it's the same first few words you're going to have to use for the exam for a hypothesis test.
The data suggests.
Could say that, but the way I put it is there is statistically insignificant. Put too many ISTs. Insignificant evidence to conclude that the population mean, population proportion of all American Hispanics who think race is the most important problem in the US. So we have insignificant evidence to show that this population is, or actually differs from, and I'm going to copy and paste, the population proportion of all, and it'll be Hispanics, and African Americans who think it's the most important problem. Any questions on the conclusion? Any questions? That one's a the. Any questions on the conclusion?
What did the left bound or the bounds mean?
Oh, that was a confidence interval. So this was a confidence interval. So if you get a negative value, that means that the second must have been bigger than the first Does that make sense? So that means the second is no more than 0.02 bigger than the first. So that means that the African Americans are no more than 2% more likely than the Hispanics to say that race is the most important factor. Whereas the upper bound is the opposite. So now we have 14%, but it's positive. So that means the first is bigger than the second. So we would say that the Hispanics are no more than 14% more likely than the African Americans to think that race is the most important factor. Yeah, you should need to know how to interpret that. So understand it. And on the exam too, not necessarily this example, but you have to do single proportions. It's not that much different.
What would need to be the difference there for us to say that there was statistically significant evidence?
Good question. And
or for us to reject the null?
And the answer is the lower bound and upper bound have nothing to do with that.
Right, it's the p-value.
The p-value. So it would have to be less than 0.05 for the p-value. Got it? So don't get confidence intervals and p-values confused. They're different. And in fact, we could use 0.99 if we want. It is fine to use a 0.99 confidence level and a 5% level of significance. That's fine. Just to let you know. That changes things.
Oh.
Will you be asking us the confidence intervals related to the p-value and finding the hypothesis tests?
First thing, they're not related.
Okay.
Confidence intervals are not related to the p-value. Got it?
Yes.
And on your project, in project 2, do not put anything about p-values in the same paragraph as anything about confidence intervals. Got it?
Yes.
They're separate. They're different chapters. Now, this chapter, to be honest, this chapter, like at first just skipped confidence intervals completely. And I got a lot of complaint emails that, hey, how can we use OpenStax when they're skipping confidence intervals? So if you read the chapter 10 about confidence intervals, I wrote it. There's not too much that I wrote in this book. I did a lot of programming, but this one actually wrote the words. So I'll let you know that, they're really separate.
What's the difference between the confidence interval and the confidence level?
So the confidence interval is negative 0.046 to 0.17. Got it? That's the interval. The level is 0.99.
Oh, right.
So the level means that if you did another study with the same sample sizes, 180, 134, then there would be then each of these studies would give you a different confidence interval. 99% will contain the population mean difference. So the only thing that's different compared to last chapter or 2 chapters ago is the word difference, which means you need to know this stuff for the exam, except without the word difference. But everything else you need to know.
So isn't the confidence level 1 minus alpha?
No,
Never mind.
no, I use 0.05 and here I'm using 0.99. You don't have to use the same thing. Trying to emphasize that.
Wait, where did we tell it 0.05?
We looked at this 0.14 and we compared it with 0.05.
Oh, right. Okay. Yeah.
Yeah, and it's calculators don't need to have the 0.05 because it doesn't change any calculation.
Right. Okay.
Does that make sense?
Mm,
And yeah, the homework of the final, you do need to understand it. And even more important, it's a big part of project 2. Okay, it won't be for proportions, but for means, it's not much different. Okay, let me move on to the next example. And this one I made up because I think you all know what happened to me today. My big event. Maybe you don't all know. I got my shot. I got my second shot. So I made a problem up, so these numbers are totally made up. But someone could do this question because I've heard about them. So do young adults experience more severe symptoms from the second COVID shot than senior citizens? Okay, I heard that they did. Someone told me. Do I believe them? What do you think? Not until I've seen statistics, and I wasn't able to find any statistics on it. That doesn't mean that it's not true. It just means I couldn't find it. Okay, but they could be done. So this is a fictitious survey. This really wasn't done, but it could be done. 42 young adults and 38 senior citizens who all received the vaccination shot a week before were asked on a scale of 1 to 10, how severe were your symptoms? The mean for the young adults surveyed was 7.1, and the standard deviation was 0.8. And the senior citizens mean was 6.4 with the standard deviation of 1.5. What can be concluded at the 0.05 level of significance? And I'll also do a confidence interval. Any questions on the question? Okay, then what about our sample sizes? Are they big enough? What do you have to compare with? What number is important? In the last example, 5 was the key number to compare with. What's the key number on this one? Yeah, 30, because the survey is on a scale of 1 to 10, how severe are your symptoms? And somebody might say 6. Okay, it's a number. They're not going to say yes, they're not going to say no. So in particular, notice that N1 is equal to 42, which is certainly greater than 30. And N2 was equal to 38, which was greater than 30. Do you all agree? So the central limit theorem tells us we do not need to assume normality. Any questions on that little piece right there? Okay. Next, I need to write down H naught and H1. All right, what's H naught? What letter do I use?
Mu.
Yep, mu. Okay, so we're gonna have mu and then sub 1, and if you want to write sub y for young, you want, in fact, I'll do that, sub y for young, just for fun, is equal to mu sub, how about S for senior citizens? Any questions on H naught? Okay, then H1, what's the inequality for H1? So I can always copy and paste, change the not to a 1 or an A, however you feel like it. But what's the inequality? Yeah, this
That
one.
younger people had greater,
Right, so greater than,
greater
because of the keyword more.
Mhm.
You got to look for the keywords. I don't give trick questions, but if you don't see the keyword, you'll feel like it's a trick question. Any questions on that? All right, well, we can do the calculator. And I want to mention something. Are we pairing up like the first young person with the first senior citizen, or is this just a group of young people and a group of senior citizens? What do you think?
Comparing the group means,
But are we comparing individual young adults with individual senior citizens?
no.
No, and that's important, and you'll see that in a bit. So let me just write down, so I don't forget. We have 42 and 38. We had the means were 7.1 and 6.4. And our standard deviations were 0.8 and 1.5. Any questions so far? So let's go ahead and go to our calculator. Which calculator do you think I want now?
18.
Yeah, this one's 18. Notice they're independent means there's no pairing involved. So these are 2 independent samples with statistics. And we have statistics, we don't have data. So I click on that. The sample size were 42 and 38. The sample means were 7.1 and 6.4. And And the sample standard deviations were 0.8 and 1.5. Whoops. 1.5. There we go. Any questions? Let me know if I'm going too fast, by the way. Do we want less than, greater than, or not equal to?
Greater than?
Bigger than. That was H1. And what do you think a first try at a confidence level is? For something like this?
99.
Okay, we can do 99 if you want. I'll let you choose whatever you want. And the idea is you can always, with confidence levels, explore. And I want you to do that on the project. With levels of significance, you cannot explore. You make those based on type 1 and type 2 errors. All right, what do you notice? What do you see?
The p-value is less than the level of significance.
Yeah, and notice, by the way, with a 99% confidence level, either one of them could be bigger. Do you see? Negative means the second's bigger, positive means the first bigger. So this is why you got to be very careful about using a confidence interval to try and reject or fail to reject. You can't do that. But what you can do is you can use a p-value. So our p-value is about 0.007, rounded to the 3 decimals. Any questions on that? So for the confidence interval, and if you want, let's just play around, look at 90% instead. Do you think that's given us better information? Yeah. So if you wanted 90%, then you can say we got better information. And you can say we're 90% confident that the population mean answer to how bad your symptoms are is somewhere for the young people is somewhere between 2.24 and 1.16 greater than for seniors. Any questions on that? Okay, the p-value is 0.007. So let's write that out. So what do we say? If the p-value is 0.07, what's the first few words?
There is statistically significant.
Can I use strong? What do you think?
What's that?
Can I use the word strong?
Depends.
Doesn't depend. Yeah, the answer is yes, because 0.007 is less than 0.01. And that's kind of the definition of strong.
Okay, so even though our alpha was 0.05, the fact that it's.
If you want the word strong, yeah.
Yeah.
If it was say 0.03, then you wouldn't use the word strong. But you still
Okay,
say
because it's close to that alpha, that level of significance. Okay, so it's so far away that we can strongly say.
Right. You're kind of emphasizing, it's like bragging rights. You get such a small p-value, you say, I got it. Do you see? And that's kind of what this is. It's a way to brag a little more. There's strong statistically significant evidence to support the claim that the population mean answer to the survey question about COVID symptoms, I guess vaccination symptoms is higher for young adults than it is for seniors. You're right, senior citizens. Any questions on that? I have a tough question. Does that mean that young adults experience more symptoms than senior citizens? Yeah, not quite. Not
Just means
quite.
they can.
No, it means they talk about it more.
They
You see?
talk about it more. They do complain more.
They
Yes.
complain more about it. Now, it might be that they have higher symptoms, but all we have is the answer to the survey question. This is not some kind of chemical test or something. Does that make-
Right. And it's a rating scale. So
Yeah.
yeah.
So everyone has their own thinking of rating scales. Do you see?
Hmm.
But what we can say is that their answer to the survey question is higher for the population mean. Do you see that? You
Is
didn't
that
have
why
any-
you specify? Is that why you specify the answer to the survey question? Because we're not specifying that there's clinical evidence.
Right. This is not medical. This is not chemical. This is a survey question. Do you see?
Okay. Mhm.
Okay. Now, if you wanted to find out like fever, then you wouldn't ask them a question. You would take their temperature. And then you can actually say that that symptom is higher. Do you see? That's more chapter 1 and 2 stuff, right? Especially chapter 1. Any questions
For
at
that-
all? Huh?
With the beginning of that where it says there's strong statistically significant, do we just put there's strong or there is statistically strong evidence or
You should have the word statistically significant.
statistically
important.
significant?
That's more
No
important.
evidence.
Oh, did I forget that? Sorry about that. I left that
I'm
out.
just wondering where the evidence goes after
Yeah,
significant.
that should go
Okay,
after. Sorry
thank
about
you.
that. No, that was my mistake. Even Google is yelling at me for it.
So when we reject the null hypothesis, then there is statistically significant evidence. If we fail
Exactly.
to reject, there's statistically insignificant evidence.
Exactly. Okay. Any questions on this example? Okay, I'm ready for another example. Hopefully you are too. And this is called play the tweet. I would be amazed if you can guess what that means, since I made it up. Okay. And population mean is crucial. Yeah. And I want to mention that. Do not use the word proportion if it's a survey question with means, and do not use the word means if it's a survey question with proportions. And if you write proportion mean, boy, am I going to take out points. I saw that. There were like, I think 3 of you on the discussion post that said proportion mean. And that's not good. Okay, so be careful.
I got a quick question.
Mhm.
There was the questions on the last chapter assignment,
Mhm.
explaining, what was it, the p-value? You would say that there's a blank % chance.
Yep.
What would that be for this scenario?
Okay, that's a good question. So let me do it. So if the population mean answer to the survey question is the same for young adults as it is for seniors, and if we studied or we surveyed another, and what were the sample sizes? They were 42 and 38. So 42 young adults and 38 seniors. Then there would be a 0.7%, because 0.007 is the same as 0.7% chance that the young adults from the sample, and let's go new sample, would average. So notice it's a sample mean, not a population mean, would average at least. And now we go back to, I think I put it in here. If I didn't, I have to write it in. Oh yeah, there it is. It's there anyway. So 7.1 to 6.4. 7.1 minus 6.4 is 0.7. So at least this sample would average at least 0.7 higher for the sample of young adults compared or than the sample mean for the seniors. Does that make sense? There is no short way of writing it. And are you responsible for this on exam 2? You are, but not as a comparison, but you definitely have to understand the p-value. It's not that much different.
When you say if the proportion mean answer to the survey question is the same for young adults as it is for seniors, you're meaning as compared to the first study, not to each other,
Not
right?
proportion, population mean.
I'm sorry, the population mean answer to the survey question is the same for young adults as it is for senior citizens. That's not compared to each other. Their mean is not the same. It's compared to the first study. If you
No,
did the
it's
study.
compared to each other.
If,
This is the
but
population mean is the same
is
for
their
young
mean
adults as it is for seniors. That means that if you asked every young adult in the world and you found the mean on that got the vaccine, of course, and you asked every senior citizen in the world that got the vaccine, and you took the mean, you would get the same number. Nothing to do with the 42 and 38 people.
okay.
That's why population.
The population mean answer to the survey question is
Yeah.
the
So the
same.
question is, I see one in the chat. Will you be required to write the p-value on the exam when you didn't on the homework? Absolutely yes. And the hope is that you write it on the homework so that you practice. And you were required to write it. You were required to write it for the discussion post assignment. So you already have had to do that and got graded on it. So you definitely need to do that. So I recommend if you're going to be studying for the test, make sure that you practice writing a lot. And I'd say typing a lot since it's all in typing now. Okay, I think I want to move to the next example because it's already almost 7. Okay, so here's something I noticed, and it's called play the tweet. Okay, I made it up. This is not a statistics word. It's not a word that anyone's ever heard of except myself, except a few friends that I told. And that is I noticed something. And it was 4 years ago. Okay, a little bit less than 4 years ago. And that was every time Trump tweeted about China, about trade with China, the stock market went down. I don't know if anyone noticed that. Did any of you notice that? So then I went and looked at different stocks to see which one seems to be going down more than others. And then it comes back up because that's the whole point. And the stock I found was NVIDIA. You ever heard of NVIDIA? So NVIDIA, if you don't know it, it's a chip company for gaming, mostly, computer chip company for gaming. And what I did is I tabulated the stock price just before he gave the tweet versus the stock price the stock price just after he gave the tweet, the kind of the reactional stock price, and the stock price a week later. And this is what I found. Any questions on the idea here? And what I did is I wrote down a null and alternative hypothesis. So this is different than the other examples. First thing, and this should be really obvious, is this quantitative or is this yes, no?
Quantitative.
Yeah, this is quantitative. I mean, look, I got the data given, it's all numbers. This is quantitative. But now here's the next thing. Are these ordered in a special way so that the first is paired with the second, that the 106 is paired with 113, the 110 is paired with 124, etc.? Or is it just this group and this other group that have nothing to do with each other? What do you think?
They're paired.
Yeah,
They're
these are
paired.
paired. So this is a paired sample. Okay, also called dependent samples. Any questions on that? Okay, because of that, here's what we do. First, H naught, you should all be used to that. And now I'm gonna write down, because they're paired, what I really want to find out is what is the mean difference, the paired mean difference. So we can actually think of the pairing and just subtract 113 minus 106 and use that value, which is 7. And then 124 minus 110, that's 14. Does that make sense? So I'm going to call that mu sub d. What do you think D stands for in this example?
Day of.
Good try, but it's not the day of, right? Because we're looking at tweet day versus 1 week later. It's a math word, but not a hard math word.
Beta.
Good try. Difference. So D stands for difference. It's the mean difference. So we say mu sub D is equal to 0. So if I'm wrong and tweeting has nothing to do with stock prices, doesn't go back up, then mu sub D equals 0. Do you agree? And then we do H1. And what's the inequality here? What do I think is happening? Or what did I think was happening?
The difference is that a week later it goes back up.
Right, and if it goes back up and you subtract, you get a positive or negative value.
Yeah.
First minus second, positive or negative?
Negative.
Yeah, less than 0. Any questions on that? Is that clear? Okay, this is a small sample size. That's all I had. How many tweets can you wait for until you start getting greedy and start buying stock? Does that make sense? Okay, and then I recalibrated after another 6 months. So the next thing I do is I go to my calculator. And let me write this down so I can remember it. Actually, I can do it this way. There's a way to copy and paste tables. I think this works. We'll see. And which calculator do you think it is?
Two dependent samples with data.
Yep, it says number 20, 2 dependent samples with data. And the first data, I can paste it in, put commas. Tables tend to copy and paste without commas, they just have spaces, so I'll put commas. And then I'll do the same with the other one. And it's important the order. You can't change the order because paired data doesn't, the order is important. You have to keep them paired. Any questions on this? Okay. And then less than, greater than, or not equal to?
Less than.
Less than. So keep the less than. And just for fun, and not just for fun, actually, it's important. I'm going to do a 90% confidence interval. And one reason for that is this is kind of day trading. I call this fun money. I'm not gonna mortgage my house to do this because with a sample size of 6, it's a bad idea to mortgage your house. Do you agree? So I actually invested around $10,000. Okay, each time, by the way. So I invested, I bought, and then I sold a week later, and then I bought, and then I sold a week later, and I kept doing that. Okay, and I hit calculate. What do you notice? What do you see about a p-value?
Pretty small.
Yeah, this is definitely smaller than 0.05. Okay, and again, with a small sample size, you better not get too greedy. Okay, look at the lower and upper bound. Okay, now remember, this is this is how many dollars out of a little more than $100 price that I had to pay. So it's pretty close to the percent. So this means each time I'm likely to make somewhere between 2% and 13%. You got to round down a little because these numbers are a little over 100. Do you think that's a good? Do you think it's a good idea to invest that?
Yeah.
Yeah. Do you think I did?
Yes.
Yeah. And I made, so out of my $10,000, I made about $20,000 in a year.
So is this calculator taking the difference between data 1 and data 2?
Yeah. So if you look at the data diffs, -4, -7, -14, -5, 4, etc. Do you see those?
Mm-hmm.
Those are the differences. Those are, if you subtract, that's what you get. And
So
in terms of the way I programmed it, I took these numbers and then I did just a regular old t-test for a single population mean, because that's what this
yeah.
does.
Okay, I was gonna ask if you did anything differently other than looking at the differences.
Right. So I needed to do the subtraction.
Okay.
The negative in the lower and upper bounds,
Mhm.
does that tell us that it goes down, or is that insignificant when it comes to the percentages that it can fluctuate?
Okay.
or-
So remember that you're subtracting. So 106 minus 113. So if data 2 is bigger, you get a negative number.
Right, okay, okay.
So now we're
Yes.
looking at between $2 and $13 higher than the price you paid.
Okay.
And that's a 1 week change. 1 week is not long, right? If you multiplied that by, you know, how many times do you think Trump tweeted a year about China? There's a lot of times. I don't know if anyone paid attention, but I did because I made a lot of money out of it. Okay. Had I mortgaged my house and sold everything I had just to do this, I'd probably made $50 million on it. But then if it didn't work, then I'm screwed. So this is what I call play money. You don't put in like your entire life savings into this. Any questions on this? And this is real. This I really did. And why can't I do it now?
Trump's not president.
Trump's
He's
not president.
He's
And
not
I've been
tweeting
watching
China.
Biden. I've been watching Biden, and do you know how many times he tweets about something like China? I don't know if he's ever tweeted. So I can't make money on him yet. But I'm watching. And if there's something I can find a pattern on, then I'm going to make more money. And I do that.
And
for
let
every
us know.
Yeah.
I'm trying my hand at day trading, so let me know.
Day trading's tough. You got to really research to find out differences. You can't just do numbers because you have to do politics stuff too, because there's enough mathematicians like me that do the numbers. Okay, just let you know. Any questions on this example so far? Let me just write down the answer because we're through a lot of time. So there is statistically significant evidence to support the claim that the population mean, NVIDIA stock price is higher 1 week after the tweet than it was than the day of the tweet. Any questions on this? There's a but here. What's the but? And this is why I didn't invest my entire house on this. And life savings. What can we say? What's the problem? But
Trump isn't tweeting about China anymore.
no. That's not why I'm saying you can't make money now. But why should I have worried a little bit when I made this decision?
It was a small sample size.
Exactly. But the sample size, with a difference, you only have one sample size, by the way, is 6, which is less than, so now which is less than 31 by a lot. So we have to assume normality, which is dangerous, by the way. Okay, I mean, there's no reason to think it's normal, but that's all I can do. Any questions? Why didn't I wait till it happened, over 30 times?
And it might stop happening.
What's that? It might start happening.
No, stop.
Yeah, it might stop happening. And in particular, I don't think it happened 30 times. I did buy it a lot. But when the first impeachment trial happened, that was the end of his tweets about China. I don't know if anyone followed the news. I watched that because I was making a lot of money. So you can't just wait, because if you wait, there'll be a new president or something will happen. So this is why you sometimes have to make that decision. Any questions on this example? Okay, now to talk about the exam. So as I mentioned, exam 2, you have Thursday, Saturday, or Sunday. And that's, I think, 6 in the evening, 8 in the morning, or 11 in the morning, if I remember right, the start times for the 3. And so that's the same. It's going to be proctorio. So the style of test is exactly the same in terms of proctorio. Sorry about that, but I don't have a lot of choice. So it's going to be a proctorio test. So you could do the proctorio quiz again, but if it worked for you on the first exam, there's a really good chance it'll work on the second exam unless you changed computers or something. And here's the questions. So number 1, do you recognize it?
Yep.
Yep, you should. It's exactly the same, copy and paste from exam 1. So that's the honesty clause. You need to be honest. Okay, 2 through 7 are true false questions. Got it? What are some good ways of practicing true falses?
The assignments.
Yeah, the assignments. And like the assignments, the computer grades the true falses. There's no partial credit. It's true or false, period. Okay, any questions on that? Okay, question number 8. I will tell you has a paragraph. This isn't all of number 8. Otherwise, good luck trying to do this. There's a paragraph at the top, and then it says, state the null and alternative hypotheses. Number 2 is find the test statistic and p-value. Number 3 is write your conclusion in the context of the study. And number 3 is based on part 3, either a type 1 error, either a type 1 error or a type 2 error is of concern. State which one and discuss the repercussions of this error. Okay, hopefully you're starting to recognize these questions. Any questions on any of these parts? Okay, number 9. Number 9, I give you a paragraph, and then it says state the null and alternative hypotheses. Write down the test you're using and calculate the test statistic and p-value. What should be part of the conclusion? So the conclusion should start with there is statistically. And the next word, I'm not going to tell you, because that depends on the problem. Does that make sense? And nowhere does it say interpret the p-value or level of significance, so don't waste your time. Got it? On number 9, that's different, but for number 8, don't waste your time. Okay, number 9. Number 2 is write the test you're using, calculate the test statistic and p-value. Number 3 is use a complete sentence to state your results in the context of the study. What are the first words of number 3?
There is significant, there is statistically.
Yeah, there is statistically. The next word you don't know. I'm not going to tell you. Okay, number 4. Number 4 is the one I ask you to interpret the level of significance. Okay, and number 5 is where I ask you to interpret the p-value. So you're going to have to do that, but you can do it on question 9, not on question 8. Any questions on this? Okay, and by the way, all of these, whether you're taking it Thursday, Saturday, or Sunday, they'll have this parts, but they're different. The paragraph will be different on which day you take. Okay, and the results could be different too. Okay, number 10 is a sample size question. How many different sample size questions have we had in our class? Different types.
2.
Not 2. Good try though. 3. 3. Sample size when you're doing a confidence interval proportion. Sample size when you're doing a confidence interval. Sample size when you're doing confidence interval proportion and you don't have a preliminary estimate. Sample size for the population proportion when you do. And then there's a sample size for the mean, population mean. So practice those. Number 11. So it'll be a paragraph and then come up with the appropriate, there'll be some percent confidence interval. Number 2 is interpret the confidence interval in the context of the study. What's the first word on number 2's answer?
With.
With.
With, okay. No excuse not to have that word written down. It'll get you started. Okay, and number 3 is whatever that percent is represents a probability, interpret the probability in the context of the study. Okay. Any questions on number 11? Okay, I want to let you know these are very standard questions, but if you don't practice, it won't go well for you. So write out a bunch of examples. Okay, number 12 is for each, write down the distribution, answer the question, decide if the assumption that the money spent per year, oh, sorry, that was from last quarter. Okay, that something else, it'll be different. That something is normally distributed is necessary for your calculations. All right, so I'll let you know that there's 2 parts on this one. How many answers do you have to have on part 1? It's an easy answer, but so many people get it wrong when they take the test. So for part 1, how many answers should you have? How many things should you be doing?
Are you talking about write down the distribution, A? Part 1?
That's one of the things you have to do for
What do you
part
mean by
1.
part 1?
Part 1, there's going to be 2 different paragraphs for number 12. There's going to be a part 1 and a part 2. Now,
Oh,
maybe,
you gotta keep them
so
ordered.
how many things should you do for part 1? It's an
3.
easy answer, huh?
3, ABC,
3.
right?
How many things
Oh,
should
I see what you're
part
saying.
2?
3.
3. Okay, I want you to write down 2 words. Okay, and maybe you'll be lying, but I can't do much about it other than take off points. Write down, if you will do that, if you'll do 3 answers for part 1 and 3 answers for part 2, write down, I promise. Put it in the chat box. I don't know what to do to make you all do it, other than like maybe make you promise, and then you won't like break your promise. Okay, the question's not changing. Part 1's gonna have a paragraph, you have to do A, B, and C. Part 2 is gonna have a paragraph, you're gonna do A, B, and C. And if you don't do part C, which is what most people forget, then you lose 1/3 of the points. That sucks, doesn't it? It's not a trick question. I'm telling you. Okay, a lot of people only do B. What symbol must be in part A? It won't be 3 paragraphs, by the way, 3 answers. Because what symbol must be in part A? See if you remember. This is, by the way, this is chapter 7. And what symbol must be in part A?
Distribution.
I'm looking for a symbol, not a word, just a symbol. You can put in the chat box if you want, if you don't remember the name of it. You remember? Yeah, there we go. Genevieve's got it. Tilde. Part A, if you remember that tilde, that'll get you going. Got it? Okay. I mean, there's other things you're going to have besides the tilde, but at least that'll get you going. So many people just leave it blank. I mean, don't even bother answering. And practice. Okay. Number 13 is a paragraph, and then come up with the appropriate 95% confidence interval. Number 2 is use a complete sentence to interpret this the confidence interval in the context of the study. And number 3 was the sample size large enough to use the normal distribution explained numerically. So I don't want just yes, no on number 3. You have to explain, you have to write down numbers. Okay, and I'll tell you, one of two different numbers is going to have to be on number 3. What are the two possibilities?
5 or 30.
5 or 30. Get those straight. Don't make a mistake on it. Don't just guess. Practice. Got it? Okay, there is no extra credit on this one. You've done the extra credit. And in fact, I even answered one of your extra credit. I spent my entire 4-day weekend writing videos for you with the LibreText calculator instead of the TI-84 for the short videos. Okay, but there's no extra credit on this one, only on the first exam. Any questions about the exam before we move to the project?
So is most of it between last week and this week?
Okay, you've seen the exam. Okay, the only thing you haven't seen, too many details on is 2 through 7, which are true false questions, which are not as many points individually. Combined, it's about 1 problem.
Is today's information from the lecture on it?
No, but if you don't understand what a hypothesis test is, good luck.
Right. Okay. But we won't be doing any paired studies.
But don't compare
That's
two
the
different means, because that won't happen but it will happen on the exam, on the final exam, sorry.
Okay. And our project.
11, let's see. There you go.
So which chapters does this cover?
7, 8, and 9.
Okay.
Yeah, which are beefy chapters, right? Okay, come up with the appropriate percent confidence interval. Explain it. That one you can do with the calculator. But I'm not going to tell you which one, because there's different calculators for confidence intervals. And you have to know how to do whether it's proportions, whether a proportion or mean with data, with statistics, that you need to practice. Does that make sense?
When will this lecture be posted onto YouTube so I can kind of go back and pause it and write this stuff down?
So the way it works is that after we say goodbye, then I hit stop. Okay, or maybe as we're saying goodbye, I hit stop. And then Zoom sends me an email, usually an hour or so later, saying, here it is. And then I click download, and it takes 5 or 10 minutes to download. And then I go to YouTube, and I post it up to YouTube, and that sometimes takes an hour. And I want to let you know there's a very good chance that I will not be awake when it's done, because I got a rough day. Hope you understand with the COVID thing, with the vaccine.
Yes, of course.
Yeah. So there's a good chance it won't be till tomorrow morning. And I've heard, like my friend who got it slept 11 hours the night of. So that could happen too. It might be later tomorrow morning. So I'll do my best, but I can't promise anything because I'm in weird health condition right now. But not something that you have to say I'm sorry or anything. I'm happy, I'm smiling a lot. Any questions on this? Okay, the next thing, which is not the last thing, is a secret word. And the secret word for this week is difference, because this week is all about looking at the difference between two means or the difference between two proportions. Any questions on that idea? Okay, so now let's talk about the project. So if I like to go to the syllabus. It's kind of a good place to go for the project. So here's the projects. And we're looking at project 2 now. They're similar to project 1, but not the same. Don't just think that you have to do the same stuff. It's not about that. The big similarity is you must work with a group. And if you have 3 people, you're better off. Less work to do, and it's safer in case someone drops or in case someone doesn't do any work. And please, put in your effort too. Okay, so that's one thing, is that there are other projects. They are group projects. I know a lot of people hate the fact that group projects and I give the same grade, whether they worked hard or not. But if I talk to people 4 years later, it's the thing they thank me the most about is a project. And they thank me that they learned about reality. Working with people is not necessarily what you expect it to be.
And we're all going to be in the real world working with and collaborating with coworkers.
Yep. And if you can't do that, then you won't do well in the working world.
And it's not that much different than collaborating with fellow students.
Absolutely. So hopefully you'll get it, and you do your best. That's all I can say, and try to do your best. Don't try to communicate with your partner a lot. Okay, and don't wait till the last minute. So let me click project 2. Okay, so the purpose of project 2 is to use confidence intervals and hypothesis testing. Okay, so I want to really focus on this. Do not have more than maybe a page or two that isn't about confidence interval and hypothesis testing. Got it? This is about hypothesis test, confidence interval and hypothesis testing. You can write all you want, and I just skim through it. If you start putting pie charts and stuff, I almost ignore it. Just let you know. So this is about confidence interval and hypothesis testing. Got it? So your first step actually is to make sure you have partners. Then your next step, so it's definitely a step-by-step process. And we learned that about hypothesis testing, is it's very step-by-step. So your next step after finding partners is decide what you're interested in researching and design your study to collect your data. So you should write down your null hypothesis and your alternative hypothesis in both symbols and words. Is that clear? Okay. Just a note, where should you write that down? Any thoughts?
The discussion board?
Yeah, the project 2 discussion board. So write that down and I'll let you know if it'll work. Okay, it's going to have to be quantitative and it has to be something you can get data for, but doesn't have to be a survey question actually. Could be collecting data, that's fine. Okay, but you should write down your null hypothesis and your alternative hypothesis and maybe how you're going to collect the data. Okay, you are allowed to use convenience sampling, just let you know. You don't have to do a survey where you ask people. You can do a survey where you're looking at finding data. So I don't know, something like, I think that, I don't know, maybe younger actors make less money than older actors. That would be something I'm not very interested in, but you might be interested in terms of the population mean. And then you can go and see if you can find the salaries of all them. I don't know if you can or not, but does that make sense? You're not going to survey all your favorite actors because they're not going to answer your question, but you might be able to find it online and you might not.
Okay, so we come up with something that we're interested in and then we do research through the internet or whatever. So
do not research someone else's hypothesis test.
Got it. Thank you.
Collecting data.
We are
And that
collecting
data, you're allowed to use the internet. So for example, if you want to find out, do skis cost more than snowboards? What's more money? Well, that's easy to collect the data. How do you collect the data?
Price check. And then you have to think about all the equipment.
You go to maybe Amazon. Yeah, but you're going to probably go to a bunch of different places like Amazon and REI and a bunch of places, look at their skis, look at their, so that way you can do it by paired data. Do you see? And paired data is better if you can. And then you go to all these different companies and look at the difference in kind of their first show up of skis and their first show up of snowboards. I don't know, something like that. So notice you're not surveying anyone. And you could do it by, I don't know, the companies that you can find or something like that. So it's okay to be, it's okay to have a biased sample, but you have to admit it, that's all. You don't lose points to admit it, you just have to admit it. And it's okay to use convenience sampling, you just have to admit it. Any questions on that? In the real world is not okay, by the way. But again, I can only ask you to do so much. Okay, after I tell you that it's gonna work, okay, or I tell you it's almost going to work, change this, and you change it. You should also identify the client, by the way, just like project 1. Identify who might be interested. If nobody's interested in what you're doing, the project won't work because it's boring. Is that clear? Okay, then you're going to go into the spreadsheet program. You're not allowed to use this calculator. You have to use a spreadsheet program, which is actually very easy to use. I programmed it also. You could use a different spreadsheet program, but this one's pretty, I programmed this for the project. So let me show you. Just like project 1 had its spreadsheet program. It's the same program, it's just different buttons. So let me find it.
On the data that we can use, I
I think it would be pretty interesting to delve a little deeper on the data that we got from our project one. Are
Mhm.
we able to kind of expand on
Well,
that?
you have to have sample sizes that are large enough, which means more than 30 of each group.
Oh, okay.
You
Okay.
see?
Yeah.
Or if you're doing paired data, then we're talking about 31 companies, for example, and then you're going to look at their snowboard and their ski price. Do you see?
Yes.
So that's one thing, is that it usually doesn't work because your sample size is probably too small originally.
Yeah.
Because we saw today, again, this is a chapter 10 project. We saw today that for chapter 10, you have to make sure that your sample sizes, sizes are both large enough. Do you see?
Yeah. Makes sense. Thank you.
So
And it's
to
why I don't
elaborate,
let- it's why I don't let you use proportions, because then you need over 1,000, and I would be evil if I made you do that, right?
to elaborate on the ski and snowboard thing, when you said if we did like a paired study, let's say for instance, we looked at like REI, like you said, Amazon, Dick's Sporting Goods, blah blah blah. Those
Mhm.
we would compare the ski to the snowboard from each store,
Mhm.
and then we need 30 stores or 31.
31 stores, yeah.
Okay.
If you're doing paired. So just to let you know, in the spreadsheet, I don't know if you can see this, but at the bottom, there's a 2var stats, and that's the one you're going to use. The first thing you're going to do is highlight and hit the backspace, basically to erase it. Okay. And by the way, if you use the spreadsheet, you don't even have to do new whatever, save as a new thing, because you've got it, it's yours. If you haven't used it before, then you have to do save as a new thing. And then you just put your first number in. I don't know, 150 and 220. And then the second numbers might be 198 and 199. Okay, you just put your data in, and you'll notice what I did is what you have to know how to do is to move your eyeballs. Do you think you can do that? So you will see that there's difference independent, and there's stats for dependent difference, because that's what we talked about today. You're only going to do one of these. Whichever one you're doing is what you should do, and you have to know which one to do. And I give you have your hypothesis test. So one of these is going to be yours, whether it's two-tailed, right-tailed, or left-tailed. And I give you the t-value, the test statistic. Change your level of confidence, play around, compare them, write about each type of level of confidence, and then make a decision on which you want to use. Does that make sense? So do 90, do 95, and also do 99, and decide which is best for this study. Any questions on that idea? I think I forgot the decimal place. Oh, no, it's percent, sorry. Is that right? I think it's 0.99. Let me look at that. Yeah, it should be point. There we go. Any questions on this idea? Standard error, whether you're doing independent or whether you're doing dependent. Standard error is given, and I want a whole paragraph on it. Remember chapter 7, a big part of that was standard error. So the standard error helps you decide whether or not you had a large enough sample size for your confidence interval and also for your hypothesis test, and they're different. It also tells you in the number itself, what does it represent? So you should talk about all of that stuff. Okay, now if you don't want to write it as a paragraph, you can include it, and that's even better, include it in each of the pieces. Include what does the standard error tell you about the hypothesis test for a difference. Any questions on that? Okay, so here's all the stats that you have to calculate. And just like project 1, you need to copy, and you can either copy or do a screenshot and then paste it into your project. Got it? So it needs to be there. So either you're going to do this N and O, or you can do the J and K, depending on which your particular study is. So far, so good? Let me get to that one. So again, you talk about the sampling technique. Don't spend a lot of time talking about it. You just talk about it. Okay. It's a comparison study like what we did today. It's not proportions, it's means. So the variables must be quantitative and subtractable. So again, you wouldn't say like, how much did snowboards cost and how many centimeters are they? What's wrong with that?
Different units, so you can't really compare them.
Yeah, it doesn't make any sense to say, well, you know, it was $280 for the snowboard, but it was, you know, 165 centimeters. So obviously the price is more than the centimeters. No one cares about that. Do you see that? You have to compare something that people care about the comparison when you're subtracting.
So do you subtract the difference between skis and snowboards or between the different snowboards from different places?
In my example, skis and snowboards. Don't do skis and snowboards, by the way.
I know, I'm just using your example.
Yeah. So it's ski, and in this case, it would be dependent. So you would say, you know, maybe ski for REI minus, you know, and ski for, and snowboard for REI. And then you would do ski for Joe's snowboard shop and snow. Does that make sense? Or Joe's snow shop. And then you look at their skis and snowboards, and each that would be the data. Any questions on that? Okay, so just a note, and this is very important, is that you have to emphasize that you're using a difference. Remember the secret word? So that should help you. Okay, so the word population mean difference should be in your project many times, those words. Population mean difference, because that's what the project's all about. Any questions on that? Okay, notice other than the means, you don't need to go into any detail about the individual sample statistics. Is that clear? So don't even talk about the standard deviation for the first sample. No one cares. We're doing a combined study. Do you see that? So focus on the fact that we're doing combined stuff. Okay, now, if you're doing a independent samples test, then the two means are important. Okay, if you're going to be using a source to get like prices or whatever you're doing, make sure you cite your source. I'm not picky about MLA or anything, but I am picky that you have to actually say where you got it. So if you give me a link, that's good enough. Any questions on that? This isn't an English class, but you should still cite your sources. Okay. Let's see. Because the standard error is confusing for a lot of people, I made a video on it. I'll let you watch that video. So promise me you'll watch this video on analyzing the standard error. Okay, you should have a confidence interval. And by the way, in the hypothesis testing, you should do the order at which you do hypothesis testing. So remember, the first thing is idea. The next thing is you collect your data. Or sorry, the next thing after the idea is you write down the type 1 and type 2 error ramifications. And then you decide on your level of significance. Then you collect your data. Then you put the data in the spreadsheet. And then you read the spreadsheet statistics, see what you get to do. And then you write a conclusion. So this one's in order. Now, for the confidence interval, the order is not quite as important. But for the hypothesis test, it's important. And make sure that you keep that in the order for your writing also for the hypothesis test. Okay. In the confidence interval, be sure to give the reason for choosing the confidence level and what it means. Okay, don't just say, I use 5% level of significance, therefore 95% confidence level. Remember I said that that's not what it's about? You should be looking at the different confidence intervals and saying which one works best for your project. And it should have nothing to do with the p-value or the level of significance. Any questions on that?
So is that kind of based on like the decisions or like the implications of your data? Like if making a decision off the data is very...
How bad it is to be wrong.
Yeah, like if you're looking at the strength of like a
Yeah,
bridge.
and also,
beam.
is your confidence interval too wide to actually give you any information?
Okay,
If it is, you might want to go to 90%. Do you see?
yeah.
Or if it's very narrow at 90%, go to 95, and it's still really narrow, go to 99. Because then you can be very confident and you have a nice narrow interval. That's the best. That doesn't always
So-
happen, but sometimes it does.
So this is like last week when we were doing the first KISS example, how we said that it's useless to say that we were 99% confident that it was between like 0 and 80 or whatever. And we
Exactly.
decided that going
Right.
for a broader one makes more sense because then we narrowed it down to like high school age.
Right. So you're going to have to do that with your project.
Great,
Okay?
thank you.
Yeah. And I have no idea whether 90 or 95 or 99 is going to be best for your project because you can't know until you've looked at the data. Whereas level of significance has to be done before you look at the data. That should be done right after you state your hypothesis test and then the ramifications of a type 1, type 2 error. Okay? And you want to intermingle the standard error throughout. Any questions on all this? Okay, for the hypothesis test, and actually for all of it, be careful about just copying and pasting what I put in the discussion board for interpreting the p-value, for example. Okay, you could do that, but then I want about 4 or 5 sentences after that explaining what it means and what the client is going to do because of it. Does that make sense? So if all you have is the one sentence that you've been doing on the homework, that's not enough. You need to talk about how is the client going to use the p-value information, the level of significance information, the confidence level information, and the confidence interval information. Should be all about your client. And don't use I. It's all about your client, not about you. Got it? Okay, you should talk about your assumptions. Okay. Any questions on that? And conclusion? And then a little bit on why your topic and results are important. That's probably good in the intro. And then at the very end, you might want to talk about, well, if you could do a bigger study, what might you do to get more information? That's always a good thing in any paper. Okay, I also put a feedback link on drafts of Project 2 that got sent to me. Okay, and it's the same rule for the Project 2 draft as Project 1. Do you remember the rule for Project 1 draft? Timeline? Can you remember?
If you
That
send
you'll
it
look it over if we send it early.
And how early?
The Thursday before it's due,
But not any time. What time?
8 a.m.
8 a.m. Okay, but I'm going to do the same as Project 1 in that it's a first come, first serve. So if you send it on Wednesday in the morning, I'll probably be able to get back to you on Wednesday. If you send it at Thursday at 7:59 a.m., it might be Friday before I get back to you. Okay, because I'm going to have to read everybody's. Does that make sense? And you'd be last because if you send it 8:01 a.m., I don't even look at it. I'll send you an email back saying, well, do your best. Any questions at all about the project before we call it a day? I went a little over because we had a lot to talk about today. Okay, let me stop the share and stop the recording.